This is Dr. D. Khalandar Basha working as Associate Professor in Institute of Aeronautical Engineering. Continues to a domain specific, we go and see a few more applications under the course Principles of IoT. The slides are prepared by referring the textbooks Internet of Things, a hands-on approach, authors Akshardeep Wagh and Vijay Visetti, publication Universities Press. So in the last session, we have discussed the home automation, cities, environment, energy. Now we will see the remaining like energy, retail, logistics, agriculture, industry, health and lifestyle. Now we will see the next application, which is energy. So for this energy, we can have the smart grids, prognostic health management, renewable energy integration. Under smart grids, the smart grid is a data communication network integrated with the electrical grid that collects and analyzes data captured in near real time about power transmission, distribution, and consumption. Smart grid technology provides predictive information and recommendations to utilities, their suppliers, consumers on how best to manage power. The smart grid collects data regarding electricity generation, either it may be a centralized or a distributed, consumption that is instantaneous or predictive, storage either it is conservative of energy into other forms, distribution and equipment with health data. The smart grid uses high-speed, fully integrated two-way communication technologies for real-time information and power exchange. By using IoT-based sensing and measurement technologies, the health of equipment and the integrity of the grid can be evaluated. Smart meters can capture a real-time consumption, remotely control the consumption of the electricity and remotely switch off supply when it is required. Power thefts can be prevented using smart metering. By analyzing the data on power generation, transmission and consumption, smart grids can improve efficiency throughout the electric system. The storage, collection and analysis of the smart grid data in cloud can help in dynamic optimization of system operation, maintenance and planning. The cloud-based monitoring of smart grids data can improve energy usage levels via energy feedback to users coupled with the real-time pricing information. The real-time demand response and management strategies can be used for lowering peak demand overload via appliances control and energy storage mechanism. Conditions monitoring data collected from the power generation and transmission system can help in detecting faults and predicting outages. Renewable energy systems. Due to the variability in the output form from the renewable energy sources such as solar and wind, integrating them into the grid can cause grid stability and reliability problems. Variable output produce local voltage swings that can impact power quality. Existing grids were designed to handle power flows from centralized generation sources to the loads through transmission and distribution lines. When distributed renewable energy sources are integrated into the grid, they create power bidirectional power flows for which the grids were not originally designed. The IoT-based system integrate with the transformers at the point of interconnection, measures the electrical variables, and how much power is fed into the grid. To ensure the grid stability, one solution is to simply cut off the overproduction. For wind energy system, the closed loop controls can be used to regulate the voltage at points of interaction, which coordinate wind turbines outputs and provide a reactive power output. So, next, prognostics. Energy systems like smart grids, power plants, wind turbine farms, for instance, have a large number of critical components that must function correctly so that the system can perform their operations correctly. For example, a wind turbine have a number of critical components like bearings, next turning gears, for instance, that must be monitored carefully, as wear and tear in such critical component or sudden change in operating conditions of the machine can result in failures. In systems such as power grids, a real-time information is collected using a specialized electrical sensors at the substations. So the information which is received from the sensors must be monitored in real time for estimating the state of system and for prediction failures. So the energy systems have thousands of sensors that gather real-time maintenance data continuously for condition monitoring and failure prediction purposes. The IoT-based prognostic real-time health management system can predict performance on missions or energy systems by analyzing the extent of deviation of a system from its normal operating profiles. Analyzing a massive amount of maintenance, their data collected from sensor in energy systems and equipment can provide predictions for the impending the failures to improve their reliability and availability. So this potentially impending the failures so that their reliability and availability can be improved. The health management system have been developed for a different energy system. OpenPDC is a set of application processing of streaming time series data collected from phasor measurement unit that we call as PMUs in real time. A generic framework for storage, processing, and analysis of massive mission maintenance data collected from a large number of sensors embedded in industrial missions in a cloud computing environment. The next application we can see in the retail. So in the retail, either we can have inventory monitoring, or we can have the smart shopping applications, and we can have smart payments. So first we will see the inventory management, where we can give the details of how much amount of stock is there, what are the various items are existing. This kind of thing we can have in the inventory management, where each and every item is tagged with a special kind of identification kind of thing by using tags. So inventory management for retail has become increasing importance in recent years with a growing competition. While overstocking of products can result in additional storage expenses and risk in case of perishable, understocking can lead to loss of revenue. So IoT system using RFIDs, where RFID stands for radio frequency identification tags, can help in inventory management and maintaining the right inventory levels. The RFID tags attached to the products allow them to be tracked to detect the inventory levels accurately, and low stock products can be replenished. So the tracking can be done using RFID readers attached to the retail store shelves or in the warehouse. IoT system enable remote monitoring of inventory using the data collected by the RFID readers. Next, we will see smart payments. Smart payment solutions such as contactless payments powered by technologies such as NFC, that is near field communication, and Bluetooth. The near field communication is a set of standard for smartphones and other devices to communicate with each other by bringing them into proximity or by touching them. Customers can store the credit card information in the NFC enabled smartphones and make payments by bringing the smartphones near the point of sale terminals. NFC may use in combination with Bluetooth, where the near field communication offers a low speed initial pairing of the device to establish a Bluetooth connection, while the actual data transfer will be takes place over Bluetooth. The next one is smart vending machines. The smart vending machine connected to the internet allow remote monitoring of inventory levels, elastic pricing of products, promotions, and contactless payments using NFC. Smartphone applications that communication with the smart vending machine allow user preferences to be remembered and learned with the time. When a user moves from one vending machine to the other and pairs the smartphone with the vending machine, a user specific interface is presented. Users can save their preferences and favorite products. So, sensors in a smart vending monitoring its operations and send the data to the cloud, which can be used for predictive maintenance. Smart vending machine can communicate with other vending machines in their vicinity and share their inventory levels so that customers can route it to the nearest machine in case of a product goes out of the stock in a machine. So for a perishable items, the smart vending machine can reduce the price as the expiry date nears. New products can be recommended to the customers based upon the purchase history and preferences. The next applications related to logistics, which is smart logistics. It is remote vehicle diagnostics, fleet tracking, shipment monitoring, and remote vehicle diagnostics. So first we will see route generation and scheduling. Modern transport systems are driven by data collected from multiple sources, which is processed to provide new services to the stakeholders. By collecting large amount of data from various sources and processing the data into useful information, the data-driven transportation system can provide the new services such as advanced routing guidance, dynamic vehicle routing, anticipating customer demands for pickup and delivery problems, for instance. Route generation and scheduling systems can generate end-to-end routes using combination of route patterns and transportation modes and a feasible schedule based upon the availability of the goods. So as the transport network grows in size and complexity, the number of possible route combination increases exponentially. The IoT based system backed by the cloud can provide the fast response to the route generation queries and can be scaled up to a large transport network. Next one is a fleet tracking. So vehicles fleet tracking system use a GPS technology to track the locations of the vehicles in real time. So the cloud-based fleet tracking system can be scaled up on the demand to handle large number of vehicles. Alerts can be generated in case of deviations in the planned routes. The vehicle locations and routes data can be aggregated and analyzed for detecting bottlenecks in the supply chain such as traffic congestion on the roads, assignments and the generation of alternate roads and supply chain optimization. So the system can analyze the message sent from the vehicles to identify unexpected incidents and depreciations between the actual and planned data so that remedial actions can be taken. Next one is shipment monitoring. In the shipment monitoring, solutions for transportation system allow monitoring the conditions inside the containers. For example, containers carrying fresh food produce can be monitored to prevent spoilage of the food. IoT-based shipment monitoring system uses sensors such as temperature, pressure, humidity, for instance, to monitor the conditions inside the container and send the data to the cloud where it can be analyzed to detect the food spoilage. So the analysis and interpretation of the data on the environmental conditions in the container and the food truck position can enable more effective routing decisions in real time. Therefore, it is possible to make remedial measures such as the food that has a limited time budget before it gets routed can be rerouted to a closer destination. Alerts can be raised to the drivers and the distributors about the transit conditions, such as container temperature exceeding the allowed limit, humidity levels are going out of the allowed limits, for instance, and corrective actions can be taken accordingly. So, for a fragile products, vibration levels during shipment can be tracked using accelerometer and gyroscopes sensor attached to the IoT devices. In a system for monitoring container integrity and operating conditions, monitors the vibration patterns of a container and it can contain contents to reveal the information related to the operating environment and integrity during transport, handling, and storage. Next, remote vehicle diagnostics. The remote vehicle diagnostic system can detect faults in the vehicle or warn of impending faults. This diagnostic system uses onboard IoT device for collecting data on vehicle operations such as speed, engine RPM, coolant temperature, fault code numbers, and status of various subsystems. Such data can be captured by integrating onboard diagnostic system with IoT device using protocols such as CAN bus. Modern commercial vehicle support onboard diagnostic, that is OBD standard such as OBD. The OBD system provides a real-time data on the status of the vehicle subsystem and diagnostics trouble codes which allow rapidly identifying the faults in the vehicle. So IoT based vehicle diagnostic system can send the vehicle data to the centralized server on the cloud where it can be analyzed to generate alerts and suggest remedial actions. In a real-time vehicle diagnostics and early fault estimation system make use of onboard vehicle diagnostics device and expert system to achieve a real-time vehicle diagnostics and fault warning. The next applications corresponding to the agriculture, where agriculture we can have a smart irrigation or we can have the greenhouse control. So smart irrigation. The smart irrigation system can improve crop yields while saving water. Smart irrigation system use IoT devices with sensors like for soil measurement to determine the amount of moisture in the soil and release the flow water through the irrigation pipes only when the moisture levels are beyond the or below the predicted threshold. Smart irrigation systems also collect moisture levels measurements on a server or in the cloud where the collected data can be analyzed to plan watering schedules. So cultivar rain cloud is a device for smart irrigation system that uses water walls, soil sensors and Wi-Fi enabled programmable computer. Next one is a greenhouse control. The greenhouse structures with the glass or plastic roofs that provides conductive environment for growth of plants. The climatological conditions inside a greenhouse can be monitored and controlled to provide the best condition for the growth of the plants. The temperature, humidity, soil moisture, light, and carbon dioxide levels are monitored using sensors, and the climatological conditions are controlled automatically using actuation devices such as valves for releasing water and switches for controlling fans. So IoT system play an important role in greenhouse control in improving the productivity. The data collected from various sensors is stored in a centralized server or in the cloud, where analysis is performed to optimize the control strategies and also correlate the productivity with the different control strategies. In the design of a wireless sensing and control system for precision greenhouse management uses a wireless sensor network to monitor and control agriculture parameters like temperature, humidity in real time for better management and maintenance of the agriculture production. The next domain is corresponding to the industry, where in the industry we can have smart lighting, already we have discussed, mission diagnostics, indoor air quality management, and M2M communication, prognostic health management, this we have discussed, emerging services we have already discussed. So now we will see a few more things which are included for the industry. One is mission diagnostics and prognostics. So, mission prognosis refers to predicting the performance of a mission by analyzing the data and the current operating conditions and how much deviation exists from the normal operating condition. So, the mission diagnostics refers to determining the cause of the mission fault. So, IoT plays a major role in both the diagnostics and diagnostic for industrial missions. Industrial missions have large number of components that must be function correctly for the mission to perform its operations. Sensors in mission can monitor the operating conditions such as temperature and vibration level. The sensor data measurements are done on timescales of few milliseconds to few seconds, which leads to generation of massive amount of data. So IoT based system integrated with a cloud based storage and analytics backend can help in storage, collection and analysis of massive mission sensors. The number of methods have been proposed for reliability analytics and fault detection in the missions. Case-based reasoning (CBR) is a commonly used method that finds solution to new problems based upon the past experience. This past experience is originated and represented as in case base. CBR is an effective technique of problem solving in the fields in which it is hard to establish quantitative mathematical models such as mission diagnostics and prognostics. Since for each mission, the data from a very large number of sensors is collected using such as high dimensional data for creation of case library reduces the case retrieval efficiency. Therefore, data reduction and feature extraction methods are used to find the representative set of features which have been same classification ability as the complete of the features. Next, indoor air quality monitoring. Monitoring indoor air quality in factories is important for health and safety workers. Harmful and toxic gases such as carbon monoxide, nitrogen dioxide, carbon dioxide, etc., can cause serious health problems. So, IoT based gas monitoring system can help in monitoring the indoor air quality using various gas sensors. The indoor air quality can vary in different locations. Wireless sensor network based IoT device can identify hazard zones so that corrective measures can be taken to ensure the proper ventilation. In a hybrid sensor system for indoor air quality monitoring is presented, which contains both stationary sensors for accurate reading and calibration and mobile sensors for coverage. In a wireless solution for indoor air quality monitoring is described that measures the environmental parameters like temperature, humidity, gases, pollutants, aerosol, and particulate matter to determine the indoor air quality. The next domain is corresponding to health and lifestyle. You can have the fitness monitoring or vital sign monitoring. We can have wearable electronic sensor. So, health and fitness monitoring, wearable IoT device that allow non-invasive and continuous monitoring of psychological parameters can help in continuous health and fitness monitoring. These wearable devices may can be in various forms such as belts or wristbands. The wearable devices form a type of wireless sensor networks called body area networks in which measurements from number of wearable devices are continuous sent to the master node, that is smartphone, which then send the data to the server or cloud-based backend for analysis and action. Healthcare providers can analyze the collected healthcare data to determine healthy health conditions or anomalies. Commonly used body sensors include body temperature, heart rate, pulse oximeter, oxygen saturation, that is SpO2 level, blood pressure, ECG, electrocardiology, movement with accelerometers, and electroencephalogram, EEG. In a wearable healthcare monitoring system uses ECG as well as SOP-O2 sensors. Fitbit wristband is a wearable device that tracks steps, distance, and calories burned during the day and sleepy quality at night. Wearable electronics. The wearable electronics such as wearable gadgets like smartwatches, smart glasses, wristband, etc. and fashion electronics with the electronics integrated in clothes and accessories that Google Glass or Moto 360 smartwatch provide various functions and features to assist our daily activities and making us lead to a healthy lifestyle. Smartwatches that run mobile operating systems such as Android iOS provide enhanced functionality beyond just timekeeping. With smartwatches, the users can search the internet, play audio, video files, and make calls with or without paid mobile devices, play games, and use various kinds of mobile applications. Smart glasses allows user to take photos and record videos, get map directions, check flight status, and search the internet by using voice commands. Smart shoes monitor walking, running speeds, and jumps with the help of embedded sensors and paid to the smartphones to visualize the data. Smart wristband can track the daily exercise and calories burned. So, in this session, we have discussed a few domain specifics like energy, industry, and agriculture, health, and lifestyles. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.